Hello everyone. Today I'll be explaining L systems but with two rules. Um, I'll be using the initiator F minus G minus G. Minus symbolizes moving to left by 120 degrees and plus symbolizes moving to the right by 120 degrees. So let me F and G both mean the same thing, moving forward by the same distance, but we're using two different variables so that we can control how the iterations increase the string and how the growth of the string happens. So basically, for F minus G, first we move forward, then turn to the left by 120 degrees, then again turn left by 120 degrees and move forward. So this basically forms a triangle. So the axioms for this are F gives F minus G plus F plus G minus F, while G is G and G. So for first iteration, this is how it will work. F becomes, okay wait, F minus G minus G. So F becomes F minus G plus F plus G minus F. So it is minus GG and minus GG. So let's see how this is drawn. So F is basically moving forward. Minus is rotating by 120 degrees. So this is 120 degrees. So F is done, minus is done. Now moving G distance forward. Now moving right by 120 degrees is approximately like this. So plus is done, forward is done. Now again plus 120 degrees. So it comes somewhat like this. And we move forward. In this direction minus 120 degrees plus forward, and then again minus 120 degrees. So we're moving like this. Minus G is done, then again we're moving one more step forward, you get a G, then minus 120 degrees, you go in this direction, and this is G and G. So basically you can notice that we have drawn four triangles over here using this algorithm. So for first iteration it works like this. So similarly for second and third iteration it works similarly. So now let me show you the code. So here's the code. Firstly, I've imported the turtle directory and I've defined D to be 120 degrees and the length of each F and G to be 10. So then I have first defined the function iterate. Over here I'll be generating the final string. So I have declared axioms, which is a list of the axioms that will be used for the L system. Num is the number of iterations and initiator is the initial axiom that we'll be using. So inside iterate I'm defining another function called translate. Translate has the current present stage of the string that we'll be using, and we will be applying the specific axioms. So initially I'm initializing result to be an empty string, and then I'm checking each and every character in the current string. If C is a constant, I'm directly appending it to the result. If C is F, then I'm appending the first axiom, which is uh, F gives rise to F minus G plus F plus G minus F, while for G it is GG. So that is what I'm doing over here. I've just printed the final result of the printed the result, which is each string after each and every iteration, to just have a understanding of what is happening. So inside the function iterate, I'm initializing result to be the first initiator, and then for each and every iteration I'm calling the function translate, and then I'm returning the result. So then I've called a function draw. In this I've given the axioms. I'm like the main axiom, that is the final string that I'm getting, and I'm initializing D and L. So over here I've given a stack so that whenever a constant or a bracket comes, so then I'll be using a stack. So then I'm calling the turtle function. For turtle I'm calling the screen, and then I'm calling a constructor turtle.turtle, and I'm giving it name Alex. So initially I'm moving the turtle to the top position, like it will be pointing forward. I'm like to the top. So that's why I've given alex.write 90, so that I hide the turtle and you can see only the lines. I've given hide turtle, and to make to for you to understand how the L system is drawn, I've given the speed to be 0, and then for each and every character in the axiom, I've given each and every function. If C is F, then I've asked it to move forward. If it's G, then also forward. If it is plus, then move to the right. Minus, left. And then if it is an open bracket, then I'm appending it to the stack. If it's a closed bracket, then I'm popping it out and I'm penning up, going to the specific position. And then I'm penning down the turtle. So I'm closing the screen only when the whole function is done. So in the main function, I've declared the axiom f minus g minus g. I can give how many ever iterations I want. I'll be giving 4 iterations, and I've called the function iterate. These are the two. This is the list containing the axioms. I'm so sorry. This is a list containing the axioms. This is f gives rise to f minus g plus g minus f, and g gives rise to gg. Over here I am mentioning the number of iterations, and this is the initial axiom that I'll be using. Then I'm passing this value into the axiom, and then I'm drawing the final thing, final string that I'm getting. That's the axiom. I'm defining that the angle to be 120 degrees and the length of each string to be 10. Now let's see how the output turns out to be. Okay, first see the file. So this is how these triangles are drawn. You can see one after other it's going, and this is after each and every iteration how the strings are generated. You can see that there is an exponential growth in the string size. So this is the video about L systems. Thank you.